Hello, good morning, good afternoon, good evening to you all, wherever you are in the world. Welcome to the latest in our now weekly Innovation at Work webinar series from MIT Sloan Executive Education. Given the challenges that we know everyone is facing due to the coronavirus COVID-19 crisis that's happening around the world, we have increased the number and frequency of our webinars and also shortened their length, as you just heard, in order to try to bring relevant, useful content and ideas to you wherever you are. And so today we're delighted to be joined by John Carrier, who is a senior lecturer at the MIT Sloan School. And John is a prolific teacher in our executive education programs, and he researches on questions around how systems actually affect organizations, whether they're producing goods or producing other kinds of services. He's originally a chemical engineer. He has an MBA from Harvard Business School and an SED from MIT. And teaches in a number of executive education courses at the Sloan School. And as you can see here, also writes a number of articles and produces his research output talking about these ideas. But today, we're very lucky that John has been willing to join us and spend a little bit of time in an interactive session where we're going to cover a practical system dynamics-based approach so that we don't miss the window of opportunity that we all know will be coming as we come out of the other end of this crisis, sooner we hope rather than later. We'll also cover a structured exercise that you can run with your team so that you can get something practical out of this session, which is always our aim. So with that, I'd like to hand over to John. Please, John, take it away.
Great, thank you, Peter. And just one thing, I'm still a little bit of a chemical engineer, and the one lesson to keep in is keep everything flowing. It's a good thing. And thank you, Peter. I'd like to thank everyone for joining in today. And although this is around digital technology, I'd like to start with an example from nature. Here's a sapling in the rainforest, and what is it doing? It's waiting for a taller tree to fall so it can take its place in the canopy before something else grows in its place. Like the sunlight reaching this sapling, demand is going to return, although the timing is not under our control. What is under our control is early detection and preparation. And today, we're going to discuss how digital technology can help us with these two steps. However, we're going to realize that even though we have technologies available today that we didn't even imagine 20 years ago, most of the success is going to depend on people and the creativity we bring to solving our current challenges. Now let's move on into the space age and discuss how we got here. An interesting fact is that under zero gravity conditions, astronauts lose up to 2% of their muscle mass every day. And why is this? When nature optimizes, it does it according to this principle of least energy. And so any resource you don't use quickly decays. Oddly enough, organizations encourage laziness in their systems during periods of stability. We lose the capability to respond to external shocks. So flash forward to today. We've just experienced 10 years of stable low growth, and now we're undergoing the shock of a generation. And this is where leaders come in. A leader's role is to override these lazy signals and keep their organization's response capability from eroding. And leaders do this through running simulations and scenarios with their team, what I like to call winning the fire drill. And most of the success that we see during execution was actually won during preparation. So what can we do? First, realize that forecasting as a means for dealing with the unexpected events is not enough. And that's demonstrated by the 2006 housing crisis, where the assumption was made that housing prices would always increase until they didn't and actually fell by 30%. What's actually in is rapid response through preparation, synchronization, and teamwork, which is key. Just like with an F1 pit crew, who relentlessly practice various scenarios for months in order to complete them in seconds when the crisis arises. So I'd like to bring us to today's question. As shown in the blue line on the left, we're seeing falling demand, but at some point, demand is going to return. The question is, we don't actually know the precise timing of when that demand is going to return, but what we do know is how we can respond to it. So if we keep the status quo, we'll follow the B curve shown by the orange line, a long lagging response. And what we'd like to do is we would like our organization to much better track the rapid recovery of demand as shown in this green curve A. So today's talk is really about how do we get our organizations off of curve B and onto curve A before this crisis subsides. And to start, let's actually look at a very famous high-tech example under similar conditions, the aborted Apollo 13 mission. Perhaps the most memorable incident is when they converted a square filter into a circular one using duct tape, immortalized in the movie. It's a great example of heroics and how a quick solution can let us all get back to normal. And there's the issue. By making a problem go away, we've done nothing to improve the system's response to the next crisis. So to make an analogy, if we fight the current disease and build no antibodies to respond to the next time, our organization learned nothing and we've put ourselves in a dangerous scenario. Now there's another example from Apollo 13 that's less memorable, but far more important. Limited power required by the crew to shut down and restart the electrical system in the service module was not part of the planned mission. However, the team was able to simulate that restart on Earth, which it failed on several times. But when they went to implement that in outer space, it worked perfectly the first time when it had to. And this is an interesting question for your team. Like this Apollo 13 mission, we have a lot of equipment, data, technology, and simulations in our own facilities, and are we using what we already have efficiently? And based on experience from PwC, more than 70% of their current digital transformation projects are using data the plant is already collecting, but sitting unused in storage. Okay, so right to the point. You can go out and purchase all the digital technology you want, but in order to extract value from it, you need a clear objective and a mechanism. And in this talk, the objective is faster response time to recovery, and the mechanism is one developed for rapid response under extreme time pressure by US Air Force Colonel John Boyd's OODA, or OODA loop. And the four elements of that loop are, first, observe. What's changed in the environment? Second, orient. What is our current state in the environment? Then third, decide. How do we adjust our current state to match the changes in the environment? And then four, what is the right action to take based on the previous steps? And we should also note that in life, we're constantly running OODA loops all the time. Think about riding a bike or driving your car to work. You've ran several hundred of these loops to get in. Now, let's actually look back at the origin of the OODA loop. Fighter jets were first used in the Korean War, which put the US F-86 at the top, the Sabre, against its Soviet counterpart, the MiG-15. Now, if we compare their performance, the MiG-15 fighter was superior in nearly every way. Top speed, maximum thrust and maneuverability. The time for the MiG to act, as we can see in this illustration here, was far quicker than the F-86. Now here's the mystery. Even though the MiG fighter acted more quickly, the F-86 had a success rate of 5 times over the MiG. So let's take a closer look at these jets, and let me show you the difference. We're going to look at the canopies, and you'll notice for the F-86, you have complete visibility behind you where you have an obstructed view with the MiG. And that's actually similar to the view you have in your supply chains. And Boyd's genius here was realizing that overall response time determines success, not simply technological superiority. And here's a question for leaders to ask. If we need to buy a minute or a second of response time, where should we shift our investment of time and money? Now, it's always tempting to invest in ACT. That's where the shiny technology is. But we also want to think about the previous 3 steps. Leading indicators for observability, for instance, might give us a greater advantage at much less cost. So here's a question for all leaders to ask. When we go to build up our capabilities to respond resiliently, are we buying toys or are we really buying time? Now the connection to digital. The way to move from curve B to curve A is to improve our OODA loops, and the way to look at digital is how we can improve these steps. The technology is a commodity, and as you can see in the picture above, we run a short hands-on exercise in my class where we take inexpensive sensors and wire them through the IoT stack to the cloud in under 90 minutes. And the purpose of that exercise is to demystify the technology, because what's most important is knowing where to put your feedback loop is your strategic advantage, which we show here in the lower diagram on how you can use data to scope down from your top level problem to a specific issue in your plant, and then use data for the diagnosis. So let's apply it. And what we'd like to do is propose a 3-step process that you can use at your own facility. So first, assemble a team. I recommend 4 to 8 people. Second, ask a set of what-if questions related to the recovery and select 2 or 3 to focus on. Don't hesitate to go back to step 1 if you need different team members. And third, whiteboard 1 or 2 of these what-if scenarios through the OODA process. And let's take a look at some of the questions you might discuss with your team around demand, supply, and operations. So for demand, you might consider questions such as the following. What if your current customer starts up production a week ahead of schedule? Could you meet that requirement? What if you're contacted by a potential customer looking for 50 to 100 prototypes quickly? Could you deliver on that? How long would it take you to find the production plans, equipment, and the front line and provide a quote? If you're asked to make parts for a completely different industry, such as ventilator parts, do you have the parts and pieces in place to do that? And for supply, you can ask questions such as, what if your current supplier no longer has your allotment of raw materials? How long would it take for you to identify and qualify a new supplier? And for operations, we can ask questions such as, can we reconfigure existing equipment or restart shutdown lines? Are the supporting services, electricity, HVAC, capable staff for repairs and parts all in place? And once we've started to ask some of these what-if questions and we see what's important, let's actually compare how long it would take versus our customer lead time. And that's what we show in the graph here. If the customer needs it in 2 weeks and our prediction is our current system can only do it in 3, where in this OODA loop can we start to find time and shorten that response time to meet the customer time? So what I'm going to do is actually walk you through these 4 steps and show you a few examples from industry to stimulate your creativity. So the first step is observe. So what I'd like you to do is consider the case of an industrial manufacturer. It would be great to get a leading indicator of increasing demand in other parts of your supply chain, because what they're seeing now, you're going to see in a week or 2, maybe even faster. And fortunately, in the digital era, companies like Machine Metrics are tracking thousands of production machines in real time. And as you can see in this graph on the left, they're providing a daily real-time uptime production for these 10,000 machines. And just what we can see is in 2020, in the blue graph, demand's fallen off production's fallen off 20%. It had a major dip on April 15th, and we're starting to see some recovery this week. This data is actually from a day from yesterday. Fantastic. Now, these companies can also help you in other ways. They can also provide you with real-time data that's on your factory floor where you can send that directly to your MES system. So now you have a real-time understanding of what's currently going on your factory floor right now. And just some of these companies are great in the information they put out. What's even better is you can reach out and talk to the CEO, and he can help you answer some of these questions. This is my colleague, Bill Bether, who's the CEO. So let's apply this. So when we go to observe, here's some questions you should ask. 1, what are some leading indicators we wish we had? 2, what digital technology can we use to get those leading indicators that we may not have even had 5 years ago? And 3, who are the right people to ask? Some of these may be in our company. Some of them may be people at our vendors, suppliers, or in other places in the supply chain who have access to this data. Now I'd like to go to Orient. So here's the situation. You work at the Children's Oncology Department at Beth Israel Hospital here in Boston. And your challenge is because of the current crisis, you have to cover your face. And this can be disturbing for the children, right? So how do you think this group at Boston Hospital reached out to overcome this problem, helping the children Orient? I'm going to show you a quick solution. See what they did? You can clearly see that's digital technology we use to create that button. But now that children can see their face, they can orient themselves to the new environment, because faces is how we socially orient ourselves. And we've also improved our own observation loop. So let's apply it. So when we try to orient, the first question we want to ask is, what is the current state of our own equipment in our facility? Where are our tools? Where are all our diagrams? If we don't know where we are, we can't reorient ourselves to changes in the environment. And finally, what digital technology can help us? This is where technology such as GPS, RFID, and ubiquitous sensors can be really valuable. And again, who are the people who are currently using these technologies, both inside and outside of our company, who can help us figure this out relatively quickly? And I'd like to give a example I just had about a month ago. I was recently on a factory floor, and the front line was actually using their iPhones. They'd taking photographs of the operating procedures and put them on their phones so they could have instant real-time access to them on the floor. So many of the solutions we're looking for, people in the front line have already started trying them, so it is a great place to start. So now to decide. Now, as managers and leaders, we all know we have to sometimes make difficult decisions, and sometimes we simply don't have time to think things through. That puts us in a dilemma. And what we'd like to understand here is, are there technologies that can help us make these decisions more quickly in real time? So as an example, consider a capital-intensive field assets such as wind turbines or oil and gas rigs, and they are in the midst of an environmental event such as high wind shear or high waves, potentially putting the assets, and even more important, the people who work on and around those assets at risk. Now, using digital twins of the asset and meteorological data, we can come up with a more precise answer as to whether the asset needs to be shut down and eliminate much of the guesswork. So companies like Excelos, who's actually an MIT STEC startup here in Cambridge, they can run stress-related scenario analyses in under 2 seconds, replacing leadership guesswork with engineering rigor. So now here's some questions you can ask when you go to apply it to make some decisions, right? Are we actually making a decision here, or is this actually a dilemma, a trade-off we don't want to make? And if that's the case, what information or calculation do we need to break that trade-off? Are we currently using simulation software for design that we could pull forward into real-time operations? And who in our company is doing this work already, and how do we pull them into our OODA loop? Then finally, it's time to act. So an interesting thing is to consider many of the routine jobs where we put people into high-risk areas. Typically, These jobs require personal protection equipment, PPE, and site preparation to complete the job safely. And the concern here is we often see cutting corners under periods of operational stress, which we're undergoing now. This is a perfect time to rethink those jobs. Can we install a camera or send in a robot or drone to minimize or eliminate the time people spend doing these hazardous and uncomfortable types of tasks? And as you can see here on the left, we can see what Ford Motor is doing. You can clearly see they're doing a inspection at about 30 feet. Normally that would require a person with a harness. They're able to do that with a drone. So they're actually able to do that job more quickly without putting people at risk. And below that, we see our own Peter Hurst, who helped pioneer telepresence at MIT Sloan several years ago, so we could bring our colleagues together when it wasn't always possible in a physical environment. And what's interesting is that same technology is currently being used in hospitals to overcome the social distancing problem, so we can still make a human connection without putting people at risk. So let's apply it. When we go to act, the first question we want to act is, who else has done this? And just as a recommendation, look for other companies and industries who've done this under more challenging circumstances. If you're doing preventive maintenance, you may want to check with the aircraft industry who's been working on this for decades. Then we want to consider what digital technologies we can use. There's plenty of vendors out there, but one question I would ask is, we should avoid using people and pencils to collect data and try to convert that digitally in real time, and particularly avoid putting people into hazardous environments. And then finally, I'd just like to wrap up with some final thoughts. And a critical point here is that time is the ultimate system property. And it's summed up extremely well by this Jack Welch quote: if the rate of change on the outside exceeds the rate of change on the inside, the end is near. So 3 things to think about as you go through this transformation is, first, this is an opportunity for us to rethink all our assumptions. And as we start to solve crisis situations, let's make sure not to make the situation worse. Second, we need to win the fire drill, i.e. we're going to do this through preparation, simulation, and analysis rather than figuring it out on the floor. This opportunity has given us some slack time in our facilities to prepare for when that demand returns. And then finally, I'd like to discuss about watch your language. And what I mean by that is it's very tempting to use terms like low-hanging fruit. The problem with that term is every problem we solve should lead to solving the next problem. So the low-hanging fruit phrase doesn't imply a sustainable transformation. The second term that we like to use is optimization, right? And in fact, we're not trying to optimize here. We're actually trying to adapt. And optimization actually leads to the static, unprepared organizations we've had for our current crisis. So with that, I'd like to conclude my talk, and then Peter, we could reach out and address some questions.
Oh, great. Thanks, John. So we've been getting a lot of questions coming in while you've been talking, and we've got time, I think, to probably address a couple of them. One set have to do with, you've been talking about the role of technology and digital technology here, and there's a question that if we're trying to be able to respond quickly and agilely, these are often very big projects. And moreover, we all know that many large projects tend to fail or disappoint in terms of their outcomes. So what should companies be doing to avoid those traps and maximize success?
Great question. So first is, you've probably heard in many other places, start small, but I want to give some more detailed places to start small. And one of the things I notice everywhere I go is when companies or factories change over from product A to product B, they're very slow at it. And we already have most of the digital technology we need. So I spend a great deal of my time shooting films on iPhones and analyzing that and using that to reduce changeover times by 25 to 50%, right? And now we're building the capability to change and adapt quickly. So my point is, we need to start on the factory floor, and we need to see how can we save 15 to 30 minutes today, rather than saying, how do we save 20% of our time over a 6-month time frame? And then finally, use the technology we have, right? Just because we're familiar with the iPhone doesn't mean it's not digital technology.
Great, thank you. Related to that, something you just said then, a few people have been asking, a lot of the learning that you're talking about here happened in the context of manufacturing and physical kinds of activities. And the question is, how does that translate? Is that relevant? Have you seen people in other sectors using these same approaches, and how does that work?
So great question. I started my career in physical manufacturing, which I still do, and I do more work in back office knowledge and information. And I learned something that shocked me. Despite everything I learned in textbooks, electrons move more slowly than protons and neutrons. And if you think electrons don't move slowly, look how long it takes to produce an invoice. And what I did in a most recent project is I took my learnings from videoing and filming on the factory floor, and I actually videoed knowledge workers on how they did their work and then passed on the information. 95% of the time, when someone does knowledge work, it goes and sits in somebody else's basket. And so if you actually watch a value stream of how people do their work at their computers and where the work sits, you're going to find simple hang-ups that will surprise you. And where the technology is really going these days is what's under robotic process automation. And anyone who's ever written a simple macro to transfer database information has really touched into that. So we're going to see a much bigger use of RPA, robotic process automation, in the future. However, we can start building prototypes with not only with simple applications from Excel using macros, but the vendors actually give you a trial software so you can try it at a small scale and solve an important problem without covering the entire organization. So I think it's actually going to be more important in information sharing than it is even in physical parts manufacturing.
Great, thanks, John. Well, on that note, we're out of time. It's passed very quickly, and I know there are a lot more questions. We will be posting a summary of other questions and some ways of thinking about and answering those to our blog soon, so watch out for messages about that. Just remains for me to thank you once again, John Carrier. And yes, I see there's a slide coming up if people would like to learn more about any of these techniques. Certainly there are some references here, and we hope that you all stay safe and are able to be productive, and that as we know it will, life returns to whatever the new normal is, that some of these ideas will help all of you with that journey to be even more agile and even more successful. And we look forward to hearing about some of those examples when you join us in our classrooms in the future. Thanks once again, John Carrier. Thank you all for joining us. Goodbye.
And thank you.